Hi everyone, today in Integrated Math 1 we're going to go over Chapter 5, Lesson 4. So here are the objectives. Make sure you write them down in your notes. Alright, so let's go over compound inequalities. So compound inequalities, the main difference that you're going to see is when we have AND or we have OR. The OR statements, you're going to see that they go away from each other. So when you graph them, they are going to be pointing away from each other. And then when you have AND inequalities, these are where they're going to overlap in the middle. So you're only going to show the overlap. So here's some examples, but we'll be going over an example so you can see exactly what I mean by this as well. Alright, so example 4. We're going to solve negative 3w plus 4, which is greater than negative 8, and 2w minus 11, which is greater than negative 19. And then we're going to graph the solution set. So negative 3w plus 4 is greater than negative 8. I remember it's greater than because it makes that weird looking G for greater than. Now we're going to go ahead and solve for w. So first thing I'm going to do is box the negative 3w, which means I need to subtract 4 to both sides, because that's the only thing left that's not inside the box on the left-hand side. So minus 4. Negative 3w, which is greater than negative 8 plus negative 4, which is negative 12. Alright, our box is going to get smaller. We're still solving for w. Box our w. And then we're going to see here we need to divide by negative 3 to both sides. Got to keep it balanced. Alright, because we divided by a negative 3 to both sides, and I'm dealing with inequalities, this is where my sign flips. I have a greater than, now it's going to change to less than. So w is less than negative 12 divided by negative 3, which is negative 4. Alright, so then we have w is less than now positive 4. Negative 12 divided by negative 3 is positive 4. So let's continue. Now we have 2w minus 11, which is greater than negative 19. Let's solve for our variable, which is w. Box the 2w, which means I need to add 11 to both sides. So we have 2w, which is greater than negative 8. I'm going to make my box smaller. Divide 2 to both sides. So w is greater than negative 4. The reason why the sign did not flip on this one is I did not divide both sides by a negative. I see that there is a negative here, but because I did not divide negative 2 to both sides, that's why I do not flip the sign. So the last part that we have is to graph the solution set. So let's make a quick little number line. So we have 0, we have negative 4, and we have positive 4. Alright, so w is less than 4, which means we're going to have an open dot because this one is less ink. Alright, so open dot here. And notice this one is going to make an arrow to the left. So I'll just kind of show a little piece here that it's going to go in that direction. And then I have w is greater than negative 4, which is open dot. And this one is me pointing to the right. So as you see here, if I was to extend both of these lines, they're going to cross over. And that's what happens when we have an AND inequality, is a crossover. Alright, so let's do this next example. We want to solve each compound inequality, then graph the solution set. So same exact idea that we just did. We have 3x plus 2, which is less than or equal to 11. Or 5x minus 8, which is greater than 22. Let's solve for x in each of these. I'm going to go a little faster in this one. Look at the previous example if you need to. Minus 2 on both sides. Then we have 3x, which is less than or equal to 9. Divide both sides by 3. I've divided both sides by a positive 3, so I do not need to flip the sign. X is less than or equal to 3. Let's continue. We're going to add 8 to both sides. We have 5x is greater than 30. Divide both sides by 5. We divided both sides by a positive number. Because of that, I'm not going to flip my sign. X is greater than 6. Last part, it does say to graph. Let's do a quick graph here. So we have 0, 3, and we have 6 here. So 3, as you see here, we're going to use more ink, which means we're going to have a full circle colored in. And this one is pointing to the left. Then we have that x is greater than 6, which means I'm going to have an open dot. And notice it's pointing to the right, which we're showing here. And remember, it said or. Because it said or, we know this is the correct graph because they're going in the opposite direction, and they're not going to run into each other. And that's it.